Hey guys, welcome back to chapter 3. What we're going to do today in chapter 3 is take those training wheels off. So we're going to get rid of orbital diagrams and learn how the periodic table predicts this path. So what we looked at in the last video was how electrons file into these homes. So they file in from the lowest energy level to the highest. We can put up to 2 electrons into each orbital or each house. And if given the opportunity, they will go as a single electron in, for example, a p orbital, go up, 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 then they'd come around and pair down, down, down. So those are some of the principles that we talked about. Then we talked about what can we learn from electron configuration. So we talked about core electrons versus valence electrons. And for us, the valence electrons piece is going to be the most important. So what electrons are available for bonding? Valence electrons. Where do we find valence electrons? We find them in the highest energy level, or that outermost shell in an orbital. And then just as a reminder, that highest energy level may not necessarily be the last term in an electron configuration. It may be broken up a little bit like this. So 2 electrons are in 4s, 4 electrons are in 4p. So this would have 6 valence electrons. One of the checks, one of the measures that I'm going to be doing as you are filling out homework, labs, and then ultimately your exam is this is the format that we use. So we're going to do 4s2, 3d10, 4p4. If you Google electron configurations, a lot of times they'll switch these 2 variables. So a lot of times they'll do 3d10, 4s2, 4p4. That is not how I teach it. That is not how we learn it. And that's a red flag indicator that you Googled that instead of pulling it out of your own brain. So just kind of a heads up there. Okay. So how does the periodic table predict these electron configurations for us? We're going to read the periodic table like a book. So think about reading a book. How do you read a book? Well, you read a book from left to right. And when you get to the end of a line, what do? You go back to the left, but you go down a line. Left to right, down, left to right, down, left to right. We're going to read the periodic table very much in the same way. So what we see here is a very strategically colored periodic table. And this strategically colored periodic table is going to help us to determine these electron configurations. So we see these blue boxes here. These blue boxes are what we call the S block. So while we're in the S block, we're going to be putting electrons into S orbitals or into those spheres. Over here, we see the P block. And when we're in the P block over here, we're going to be putting electrons into the P orbitals. Orange is our D block. And we haven't talked much about this yet, but we'll get there. Green is our F block, okay? So how do we read the periodic table like a book? How do we predict what the electron configuration is going to be? So we've got to start with an example. So let's just dive in. Let's do the electron configuration for phosphorus. So that's my destination. That's where I want to get. I'm going to start the process up here at the very top. So I start at the top left. And I see this 1 on the outside. Well, that tells me that the first electrons are going to go into the first energy level. Okay? So that's what I'm going to write down. My first electron is going to go into the first energy level. And then what block do I come into contact with? Well, an S block, of course. So the first electrons are going to go on the first energy level into an S orbital. And how many electrons are we going to put in there? We're going to put 1, 2 electrons. Okay, so reading the book left to right here. Well, when I'm over here, I'm at the end of the row. So what do? Go back to the left, go down a row. Where's the next place I'm going to put electrons? See this 2 right here? Yeah, that 2 tells me I'm in the second energy level. So I'm going to write down, so 2. And what's the next block that I come into contact with? Yep, the S block. And how many electrons are going to go in there? 1, 2. Okay. So we put 2 electrons in there. All right, so we read our book. So left to right, what's the next thing we come into contact with? We're still in the second energy level, but now we're going to start putting electrons into the p orbital, into this p block. So I'm going to go ahead and write the fact that I'm still in the second energy level. I'm still putting electrons, or I'm putting electrons now into the p orbital. And how far into the p orbital do I get? Well, I go all the way through it. My destination is down here. So how many electrons am I going to put in? 1, 2, 3, 4, 5, and 6. I'm going to fill it all the way up. Okay. Well, now I'm at the end of a row again. So what do? Go down to the next one. Where's the next place we're going to put electrons? Yeah, we see this 3 right here. So we're going to put them in the third energy level. And what block do we come into contact with? Yeah, we come into contact with the S block. And we put 2 in there. Okay. So that's done. Keep reading left to right. Excellent. So now we're still in the third energy level. This is our P block. So I'm going to start putting electrons in the third energy level in the P block. How many electrons are going to go into that P block? Well, my destination is right here. So we're going to put 1, 2, 3 electrons. Okay. So that is the electron configuration for phosphorus. And we use the periodic table to get there. Okay. Let's do another one. Make it a little bit harder here. See if you guys can do the electron configuration for, let's do calcium. Okay. Let's pause the video, do the electron configuration without clicking off of this slide. Use this slide to do it. All right, so let's read our book here. So first thing you come to, I'm going to use my pointer because I'm not going to write with you. I'm just going to say it. First thing we come to is 1s2. We come down here. The next thing you should have written down is 2s2. Still in the second energy level. 2p6. Okay. Next energy level. 3s2. 3p6. So we fill that all the way up. Next, 4s2. So it should end on that 4s2. Good. Okay. All right, so the last thing I want to talk about before moving off of this slide is this right here. So remember I told you that something silly kind of happens up here, right? So we go 1s, 2s, 2p, 3s, 3p, 4s, 3d, and then back to 4p. Well, our periodic table predicts this beautifully, okay? So let's move forward here. So here's 1s, 2s, 2p, 3s, 3p, 4s, and then we have the D block. So the one and only thing that you're going to have to memorize about this slide is this. The D block, they march to the beat of their own drum. Okay, we'll learn that very often this semester. So the D block is off by 1 energy level. So this guy right here is actually 3D. And that would make this guy right here what? Yeah, 4D. And this is 5D. And this is 6D. Okay? So these guys are off by 1 energy level. So if you can remember that fact, that one and only fact, then you can use this to solve any electron configuration problem. So I want you guys to do the electron configuration for gallium here. So go ahead and see if you can do it, and then I'll catch up to you. All right, so let's read our storybook here. Oh, not that. Pointer. All right. So you should have written down 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And now is where it gets tricky. So let me go ahead and catch up to you real quick so you can see it written out. So this is where we are. Okay. So 4s2, and what is this guy right here? Careful. Yeah, this guy is 3D. And how many electrons did we put into 3D? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 electrons. Okay. And this isn't our destination, so we still have one more electron to find a home for. So the P block is normal. He behaves the way that he's supposed to. So if we're in the P block, this is back to the 4th energy level. We're in the P block, and we put 1 electron in there. So this is the electron configuration for gallium. Okay. So if you are a chemist, and we are little chemists, you are already saying to yourselves, I'm sick of drawing numbers and letters. There's got to be an easier way to do this. There's got to be a shorthand. And good news is there is, in fact, a shorthand. So let me teach you guys that. All right. So first thing I want to point out is this family right here. We'll learn more about families in the next slideshow. But for right now, what I'll tell you is this last column here is called our noble gases. I kind of joke they're the cool kids of the periodic table. Everybody wants to be like them. So the noble gases is a point of reference for us. It's a really good point of reference. So to do an abbreviated electron configuration, our point of reference is going to be that noble gas right there. Okay. So here's our noble gases, abbreviated electron configurations. So we're going to do the abbreviated electron configuration for phosphorus. To do an abbreviated electron configuration, you're going to find the nearest noble gas behind the one that we're interested in. So phosphorus has an atomic number of 15. The closest noble gas to that behind it is neon with the atomic number of 10. So you are going to put the noble gas in brackets, not parentheses, lazy chemists, brackets. Okay, make sure you do the bracket. So I'm going to put the noble gas in a bracket. Then I'm just going to simply start reading my book from that noble gas. So I am here, neon, move forward. What's the next thing we see? 3s2. Let me get my pen. 3s2. Keep reading my book. 3p. And how many electrons did I put into 3p? put 1, 2, and 3. Okay. So that's the electron configuration, abbreviated electron configuration for phosphorus. What this does in brackets is it tells us, hey, the beginning of this electron configuration is exactly identical to neon. But the way that it differs is moving forward from neon, we've got 3s2, 3p3. Okay, so that's what the abbreviated does for us. So I'm going to click back to this slide, and I want you guys to do the abbreviated electron configuration for tin. Okay, so go ahead and pause the video and see if you can do the abbreviated electron configuration. All right, so the nearest noble gas to tin behind it is this guy right here, krypton. So I'm going to put brackets, krypton. Okay. Then I'm going to start reading my story moving forward from there. So what's the next thing that I see? I'm in the 5th energy level. I'm in the S block. I'm going to put 2 electrons there. What's the next thing I write down? Be careful. Yep, this is 4D. And I fill up 4D, so I put 10 electrons in there. We're back to the P block, so P behaves the way it should. So 5P. And how many electrons did I put in there to get to 10? Yep, I put 2. So 1, 2. So the abbreviated electron configuration for tin is krypton in brackets, and then 5s2, 4d10, 5p2. Okay. That is it for electron configurations. What we're going to do with the rest of chapter 3 is we are going to talk about properties based on these electron configurations. So that's it for electron configurations. I hope you found this helpful.